Thanks, Lance. Pleasure to be here, and nice to see all of you today. Today, I'm going to talk about the Neo4j Graph Data Platform and making your data more intelligent. Now, if you're like me, you've probably seen many people present something akin to this about how data is growing and data is also becoming the most valuable asset a company has. And something I notice is every time I see this, the number gets bigger. And what that tells me is we have not only an ongoing need to continue evolving as new kinds of data show up on the menu, but we also have a tough decision of what do we prioritize and what do we do with this data? What's the low-hanging fruit I can address next? So let's talk about how you harness your data to drive business value. And I'd like to present a threefold hypothesis for data accelerated innovation. That step one, you have a lot of connections that are likely in your existing data, in your existing databases, however, that aren't structured in a way that you can easily unlock them or monetize them or use them. So unlocking connections inside of your data represents a high value opportunity. And then number two, activating that data through AI and machine learning on the predictive side, and also through graph querying on the deterministic side. I'll talk more about that later. And then thirdly, using an environment and a platform that lends itself towards building applications quickly. So this has to do with cloud first, as you know. That's probably where most of you are targeting. But it's not just that, it's also employing the right model for the right kind of problem that gives you the right agility. Let's drill into the connections. Increasingly, connections are becoming core to building modern intelligent applications. Let's look at a few domain examples. On the personalization side, you've got people, all the things that they're connected to, that they've bought, things that they've visited, across domains, whether I'm in retail or in healthcare, media, etc. If I'm in life sciences and doing drug discovery, or I'm in cybersecurity, as we are today, there's a big opportunity for data-driven discovery and innovation. Likewise with network analysis, forecasting, and just general decision making. Here you don't necessarily have an application, but you have a human being. Data integration, just bringing together your silos. Graphs are actually quite a good way of doing that without having to remap all of your data into one big system, and then you've got yet another system. Just having a system of systems that helps you locate where the right data is and bring it all together. And then last but not least, data science and AI and machine learning. What I've observed in my years here at Neo4j is that in nearly every use case, and possibly in literally every human data-driven undertaking, that there's an axis here along. If I look at the effectiveness of a use case based on what data I use, that there's some sort of maturity curve, right? Like tech evolves in S curves, and then you have some sort of discontinuous innovation that lets you make the leap. And what we've noticed working with the graph community and with our customers is that there's this plateau that's determined by how far I can go by using data without using the connections in any sort of deep way. And here we're calling the plateau of aggregate data. Aggregate data, it's not just aggregate, it's store and retrieve as well. Once you unlock the possibility of using connections at depth, so usually this means more than depth 3 if you want to get a bit more technical. It's not just a thing, and it's not just the direct cause of that thing. It's getting into the indirect causes and the indirect context, that as soon as you bring that into any use case, that there's this new potential that emerges. And that potential can be maybe small, depending on what it is that you're doing, but in quite a number of domains, that potential can be quite enormous. And that represents the graph opportunity for your use case, and where you can learn um, from what others are doing on the market, through the Neo4j community, through our team, through your peers, uh, and also just through your own creativity and experimentation. Now, why is this, and why are graph databases unlocking this kind of opportunity, and why hasn't someone figured this out a long time ago? Um, I look at technology trends as evolving in two ways. One, you're evolving to meet a business need that's important at that time. And then secondly, you're evolving subject to constraints. And relational databases started around 40 years ago, when we hadn't yet digitized paper forms into computers. So very, very early days of digitization and business process automation. And then that was done at a time where RAM was scarce. We were dealing with spinning disk and all the limitations of that was also scarce. And so that led to a data model that was more geared towards data that's more static, and where when I break things apart, it's to bring them back together again. Not so much to arbitrarily relate things, and not so much to store ever evolving data sets. NoSQL took a subset of what relational databases are able to do, and then simplified it in order to be able to handle the high scale problem. So on the transactional side, that's technologies like key value stores and column family and document databases, where really I'm simplifying. I'm saying, all right, let's not bother with relationships at all, because I have this urgent need to solve this at scale problem of doing millions of reads and writes per second in order to, say, retrieve a shopping cart, or do, some sort of store an event, and so on. Likewise, on the big data side, that tended to be about finding needles in haystacks, so filtering and doing aggregation, not so much finding connections between data. Which brings me to graphs. What we've done at Neo4j is to focus from first principles on designing and architecting a database that takes into account this need for deeper connections and deeper levels of connectedness. So it does something that's, you could say, in a way, architecturally 180 degrees from the kinds of optimizations that NoSQL databases made to solve the problems that were important to them, and also kind of modernizing or using the latest modern architectures around how you scale, and employing that over what relational databases had available when that model came into being. And I love this quote from our customer eBay that encapsulates multiple benefits that you get when you take a graph ground up approach towards addressing graph architecturally inside of a product. Our Neo4j solution is literally thousands of times faster than the prior MySQL solution, with queries that require 10 to 100 times less code. That speaks to the benefits in value to the use case, as well as in productivity, writing less code. So graphs unlock new levels of application intelligence. Hopefully, you're starting to see this between what Jim talked about, what I'm talking about, and what else you've seen. Let's talk about what some of the analysts are saying. Gartner has this amazing observation and prediction that because graphs relate everything, by 2025, graph technologies will be used in 80% of data and analytics innovations. Again, the focus on innovation, up from just 10% in 2021, facilitating rapid decision-making across the enterprise. Gartner also, in the same report, Top 10 Trends in Data and Analytics for 2021, which appeared in February, says that up to 50% of Gartner inquiries on the topic of AI involve discussion of the use of graph technology. So there's increasingly a really close tie between what's happening in AI and how to make AI smarter and your machine learning results more predictive, and the value of graphs. And if you look at Forrester, who recently did an evaluation of different technologies in the market, is no surprise to us, just having spent our lifeblood happily building for the last decade this foundation of technology and expertise for you to use to advance your own business and use case. Let's talk about an advantage that may not be evident when first exploring graph technology. And this is something you hear talked about as being whiteboard friendly, that if I'm a business domain expert and I understand how a particular domain will work here, like this is looking at a maybe a human capital management application or some sort of CRM, more advanced recommendation with customers. It's looking at the way you logically represent and think about a model ends up being almost identical to the physical representation of the model. Now, prior to joining Neo4j back earlier in my career, I spent a lot of time working as a modeler, as a database architect, through like this multi-month process of taking a logical model, the business representation of the model, which also matches pretty closely what the developer's conception of the model is, to the database conception of the model, the logical and conceptual to the physical side. And those end up being quite different. And that results in not just extra time to get from your business concept to your implementation, but it also creates this what's called an impedance mismatch between the developer's view and the database view. And it also means that if I need to evolve the model, that can take a really long time it can take a long time to make changes and be quite impactful to an application and to a database, particularly if data is already in the database and I have new data sets coming in. So there's a big business agility benefit, both in building your initial application, particularly if you're doing something new, and as you're building your application, you've got a fast feedback loop with the business and you're trying to work out how to build things, and also for my second, third, fourth release. Another big advantage of this graph native, graph first approach is performance. And the way I look at performance is if it's a 50%, 2x, 3x improvement, that's an efficiency advantage, and that's great. That's helpful. It makes everybody's lives better. However, if you can get orders of magnitude, if I can be 1,000 times faster at something, then that's transformational. If I could be at London from where I am today on the US West Coast, 1,000 times faster, then I'd probably be having, high tea at Fortnum and Mason every day, and then back in time for my next meeting. So there's a real transformational impact in being able to amplify your performance by orders of magnitude. And this is something that happens with graphs more so at scale. So the more data you have, the more connected it is, and the deeper the level of connectedness that you're after, the more, if I'm using a relational or another NoSQL database, because those technologies aren't architected for deep levels of connectedness, you tend to slow down and grind to a halt over time. And you quickly go past the 200 millisecond, give or take threshold that an application can tolerate, or users' patience can tolerate through an application, which means that now I'm not able to do real time as quickly. Whereas with Neo4j, you end up having either completely flat or slightly increasing performance profile, which means that at scale, again, you end up with this massive difference. Oftentimes it's taking queries that took minutes or hours, or sometimes wouldn't even end, on really substantial pieces of world-class infrastructure, and taking that down to milliseconds on oftentimes a much smaller hardware footprint, because you're using a technology that's architected for doing connections. Let's move into AI and machine learning. This is borrowed from, I believe, a book authored by Rathle that I think Ben Lorica had a hand in. And it's just a classification, kind of a taxonomy of different kinds of machine learning. And really the takeaway here is, look at these pictures. Every single one of these different kinds of machine learning is a graph. So it's no surprise that over the last few years, if you go to the AI conferences and see what people are talking about and read the latest papers, that more and more AI research is featuring graphs. In fact, last year in 2020, there were more than 6,500 papers that were released in academia latest cutting edge AI research featuring graphs, which is why it's also no surprise that 50% of Gartner's inquiries on AI also feature graphs. So why is that? Here's why. If a machine learning output is only as smart as the input that you're sending in, and if we've already established, if you think back to like these double asymptotes I showed earlier, these S curves, that the quality of a use case, the value of a use case is going to be dependent on not just how far I can get with disconnected data, but being able to make this leap up into starting to use connected data. However, machine learning tools that exist today are only able to take inputs that are non-graphy, that are basically feeding data in rows and columns. So the challenge and what we want to actually do is to be able to feed information about the connections. And the good news is that we've got a whole part of our stack that's quite deeply evolved and sophisticated for doing this. Sending pattern matching queries, sending the results of graph algorithms, and sending graph embeddings, which is kind of a machine readable, more sophisticated, more modern way of doing machine learning. You can also do your machine learning in the graph for certain predictors, such as link prediction. So this is a pretty exciting area. Now, if I look at the enterprise, where do you see graphs? Applications is one. So here you have like an operational database that usually runs 24/7 because you've got users that are probably around the globe, and supports a number of different use cases. So in this case, the user might not know that there's a graph database behind the scenes. And actually, a graph database might not be the only kind of database behind the scenes. It's increasingly common to see multiple databases working side by side, especially at scale to handle different problems. The next one, number two to the left, is data scientists using graphs for graph data science to make their AI and machine learning smarter. And then the last one is this benefit that I talked about earlier, the whiteboard friendliness, really becomes evident not only when I'm developing from a modeling standpoint, but with business users when I'm actually presenting data. We've had numerous cases of we're running a proof of concept, we show the data to a business user, and the business user will leap up, point at something, and then run out of the room to go act on it, just because that level of insight is available. Another observation is that people used to dealing with spreadsheets, when seeing that same data for something like fraud detection, will soon recognize patterns looking at the shape of the graph. So it turns out that different kinds of money laundering have a shape, or different kinds of fraud have a shape. And just by showing that graph visualization to a business user, you can much more rapidly screen things in and out, reduce false positives, improve the turnaround time and the quality of a recommendation. Here's an example of that using Neo4j Bloom, which is a one product you can use for this. Linkurious is a guest speaker today, so you'll get to get a great deep dive into their product, which allows you to do some great visual analysis of the graph. Let's take an overview of the platform. So I talked about visualization at the top right. I've talked about the database handling transactions and graph analytics. Really, you see this AI feedback loop. That's the virtuous cycle of your operational application that's creating data that you analyze. That analysis gives you smarter algorithms and predictions, which flow back in the transactional world. Excuse me. There are all kinds of APIs, and we have a whole programmatic stack to make it easier to build applications for all the most popular languages, tools for development and administration, data integration, and then of course it can all run in the cloud. And speaking of cloud, something great about Neo4j is it'll run anywhere and in a variety of different modalities. So you can run it locally on your machine for development. You can run it inside of your own data center on your servers in hybrid mode, or on any number of clouds. So one common way that I'd recommend for getting started is Neo4j Aura. It's a cloud-native service, no administration. We host the database for you. It's available in a self-serve credit card swipe, pay-as-you-go, starting at $65 per month. And we've actually got a waiting list you can sign up for smaller free developer instances that'll become available on a broader basis soon. And as well as more robust enterprise options there. There's also a self-hosted option if you want to operate in your own cloud. If it's hybrid, you can basically operate and find Neo4j across all the popular cloud marketplaces. And then last but not least, we have a white glove service managed by Neo4j experts if you're doing something that's, say, multi-cloud or multi-data center and more robust and you want someone else to manage it for you. There's also an array of options with regard to scale. And as a lead into talking about those options, let me share with you what kinds of data people tend to manage with Neo4j, because there's a relationship between that and how large the data is and therefore how you want to manage it. If you look at graph scale on the y-axis and maybe graph usage maturity on the x-axis, graphs of things are oftentimes, not always, the lowest hanging fruit for getting started. Why is this? It's because graphs of locations, graphs of products, of promotions, of facilities, of people, of customers, of organizations, oftentimes just mastering those is a problem in a large company with multiple lines of business and very complex hierarchies, and you want to do more with those. Those tend to not be so voluminous. Usually you're talking like hundreds of millions, billions, maybe even smaller, but very complex data that's hard to work with and where graphs can add a lot of value. The next level out from that is transactions. This is cash register receipts, payment transactions, between individuals and parties and so on. And there in my experience, you tend to be in the hundreds of millions to hundreds of billions for a typical business, typical use case, with outliers and exceptions, of course. And then the next level out from that is if I'm tracking like clickstream and behavior, that can just go through the roof and get really, really voluminous. And in the graphs of things, each individual piece of data tends to be ultra valuable, right? This is a human being, this is a person, or this is a product. Whereas activity and behavior tends to be much more voluminous, but each atom of data is less valuable. It's more about what is the pattern telling you. And then across this range, usually if I'm on with graphs of things, billion node in relationship graph that can fit on commodity hardware these days with a replicated model. And then by doing that, that way you have the advantage of being able to spider across memory and take advantage of Neo4j's in-memory database, which gives you huge performance benefits and it's easier to manage. And then at the extreme case where I have graphs of activity and behavior, usually that's voluminous enough that you want to chop it up, unless you're just dealing with a smaller period of time. So for that, we have this architecture called Fabric that lets you partition the data. And it also gives you the best of both worlds where you can replicate the data that's less voluminous and then partition the data that's more voluminous so that your queries can run as much as possible in memory without having to jump across the network and into indexes, and things then get slower and harder to manage. And then, if you have a really high value use case that's real time and you need like sub-millisecond response times and it's graphs of activity and behavior, then you might, in exceptional cases, use exotic hardware and much larger machines. So that's the general lay of the land for scaling. A talk about cybersecurity at a cybersecurity event would not be complete without talking about security. So suffice to say that there are quite a few security features that you can leverage in Neo4j. And again, Vormetric is here today through Thales, who have a product for doing doing encryption of data at rest, which we do in partnership with them. And then Aura encrypts data at rest by default as well. So quite a number of options here. And I'll pick on schema-based security as something that's exceptionally different in a graph, because you need to do things like if I want to know if there are any nodes connected to this one, I may want to let the user know that the two things are connected, but not how they're connected. So we have a special permission for that called traverse that let you see that something's connected without viewing the details of the relationship. So there are nuances in how to do schema-based security in a graph that are handled for we've had this for a bit over a year. That was a big exciting feature in the Neo4j 4 version 4 release that's quite innovative and market leading. So your opportunity today is to work out how you can take what you learn to solve more complex and valuable problems leveraging graphs with Neo4j. Here are a number of customers who do that. Many of them actually are already using Aura today. And that is it for my talk. Stay connected and thank you for joining. And I believe we may have a bit of time for questions.
Great. Thanks so much, Philip. That was awesome. I love that presentation. Thank you so much for your time and insight.
It's a pleasure.
So we do have some questions, and I want to remind the audience that if they'd like to submit a question, they can do so by typing it into the questions tab located at the top of their screen. And if we don't get to your question, someone from Neo4j will reach out to you directly, or you can send an email to webinar@neo4j.com and we will get you pointed in the right direction. But we do have some, and I know we're a little tight on time, so we'll just take a few of these that have come in so far. And I'm going to start with this one. Earlier on in the session, you mentioned graph first, and they're wondering what that means in native graph technology.
Sure. So graphs first native graph is really has to do with, as a vendor, how do you choose to go about building your stack for customers? And really, you've got two choices. You can either take an existing technology that you have and build graphs on top of that, or you can really start from the ground up and build a solution for graphs. And in the database world, if what you're building is a database, then what you start with is usually some storage engine. So do I store the data in a way that's optimized for graphs, or for 180 degrees, which might be this high volume store and retrieve NoSQL use case. And then above that, you have your in-memory representation and your query engine and the different parts of the query engine, and your statistics and your planner and your parser and your language, all the way up to drivers. So graph native is a term that you'll hear analysts refer to, and just maybe a lingo that you'll hear around the graph community. And graph native is synonymous with graph first, which means building whatever your technology is, in our case, a graph database, graph visualization products, drivers, et cetera, with graphs in mind from first principles. And as you can imagine, usually if you're not doing that, then you might be able to get so far. But then for your high volume, high scale, more complex problems, then usually you end up needing to go with a graph first solution.
Got it. Thank you. That makes perfect sense. So here's another one. What does unlimited scalability mean in the context of graphs?
Probably the same thing it means for other technologies. I guess I see scalability as being subjective to your use case today, and then where you see yourself growing. And then if you're making a broader decision enterprise-wide to use the technology for a number of different use cases, then it's the same thing, but across multiple use cases. And when I think about scale, and when we architect the database for scale, we look at several things. So the obvious one is how much data is stored, and then having different architectures for that. About a year ago, Neo4j 4.0 introduced Fabric, which addresses the kind of the tricky problem of splitting up your graph. Because if you don't split up your graph in the right way, you then pay the price in data reliability and read and write performance. So so designing to handle both is tricky, but tricky for us as a vendor. And so we've got a way fabric, as I mentioned, of helping to have your cake and eat it too, so that you can take ultra large, like these behavioral activity kind of data sets, split up the behavior and activity, replicate the other stuff next to it, and then have a query language over it that'll split your data up and pick it up from the right place. So the other one is handling your read in, your read volumes, your write volumes, and then I'd maybe give an honorable mention to being able to have operations at scale. So backups at scale and restores at scale and database copies and creations at scale and these other kinds of operations. So release with every release, we're continuing to push the limits because data is growing, right? This is a never-ending quest for all of us, both on the user and the vendor side. But really, I look at, when you're looking at scale, know that at least from the Neo4j side, you've got a whole array of options, and then what architecture you use is something you can look to from companies that have done similar things to what it is that you're trying to do, and you can always get advice from our team.
Great, thank you. That was a great explanation. So we're at our limit, but I want to ask this one last question. So this person has limited experience with graph databases, but wants to get started. So where should they start? What's the learnings of building applications with graph databases, and where do they begin?
I would start by.
It's a big question, I know.
Yeah, sure. So the great thing about actually having an open source community and having a lot of great partners and community members and employees that have been at this for a while inside of developer relations is there are a lot of different resources out there for you. I'd recommend probably just getting started with a product. You can use this with the sandbox that's out there. You can download Neo4j Desktop, which includes kind of a development license for the Neo4j Enterprise Edition, just to run locally on your machine, and includes Bloom, includes our developer tool, the Neo4j browser, because those have some built-in learning. Obviously, there's a product documentation. If you search YouTube, you'll find all kinds of great resources. We've got a blog that's daily or close to daily with lots of resources. Search the Twitter streams, lots of good activity. There's quite a vibrant community, and lots of events out there as well. Back when we were doing physical events, there's over an event per day. Like I think in 2019, it was like 450 plus events that Neo4j either was somehow covered at. There's also learning. There's what else? Certification online, and you can get Neo4j tagged as a skill into your LinkedIn profile with the certifications. So hopefully that answers it, but there's lots of stuff out there. Oh, public Slack channel, all kinds of resources.
Yes, there is no shortage of resources for sure. So I think that is about all the time we have for your session today, Philip, but I want to thank you so much for your time, and thank the audience as well for tuning in. Our next session featuring our guests from Palo Alto Networks will be starting in just a few minutes, so stay tuned for that. Thanks again.
Thanks all. Thanks, Marilee.